is a thing of the past. As you can see, that's the title of my talk. And as Rafael already awesomely did, my name is Mitchell. So I am an event sorcerer, and yes, thank you, Nick. I'll talk about later what event sorcerer is, but let's just get right into our domain, right? So what we're going to be building, or what we're going to be talking about, is our online board game workshop shop, because everyone loves board games and everyone loves buying board games. So let's just talk about that. The couple processes we're going to handle are selling a board game, and also because everyone loves to buy board games, we're also going to be restocking a board game, right? So as you can see, these processes are very domain-oriented. These are not CRUD operations like update board game or delete board game or insert board game or whatever. These things are very domain-oriented. These things have a lot to do with our business. And this immediately ties into domain-driven design, which is literally all about the business. But domain-driven design is also known as D to D, or for the younger crowd, D to the double D. So domain-driven design, right? It's here to understand the business. It's like you try to ask questions a lot. You try to have a lot of not a lot of meetings, but you just try to figure out how the gears work. You try to figure out how departments talk to each other and how everything communicates and everything, and just try to have a clear picture of how all of that works. And again, this ties in extremely well with domain events. But what are domain events? Well, they describe a change that is important to the business, which could be board game stock was replenished in our example, right? Because update board game doesn't mean anything to us. Like update board game and then changing some value in there, that doesn't mean anything to us, right? It doesn't mean anything to the business. It doesn't give us any information. But if you look at this immediately says like what it is. It immediately explains what it is. So this is why domain events are a very good way to do this. So they're all about the language. They're all about, like, if you look at this, if you see stock, for instance, stock is one of those things where like it could mean different things between different departments, right? So it's very important to get down to one language, to agree with everyone in the business to what stock means, what replenishment means, what all of these words mean, and to kind of like create a dictionary of whatever of the language that you use inside your business. And this is very important because if you as a developer have to translate between, like, when you talk to your business, like if your business has a member, for instance, or client, and we as developers use user in our code, then constantly when that client says member or client, then you have to translate that. Like you have to think about, okay, what are you talking about again? Oh, he's talking about a user, right? And when he's talking about like stock, for instance, could be something else, or replenishment could be something else. Now, the thing about domain-driven design and event sourcing is that it's very important to get down to like one language. And the other thing about domain events is they capture change in time. So a couple bullet points of what events are. They're a log. Is this readable? Yeah, it's readable. Awesome. A history of facts. And also set in stone. So just like history, like we can't change history. We can't change what we did last night. I mean, I guess some people drank last night, but maybe you wish you didn't do that. But you can't change that because that's history. And the thing about the domain events is that these are the core concept of event sourcing. Event sourcing literally cannot work without events. So how does a domain event look then? Like what does it look like? Does it look like Quasimodo or whatever the fuck? No. What it has is it has a name and also a payload. And if you use our board game stock was replenished example, a simple event might look like this. So we have a name, and then we have a board game ID and the amount that was restocked, right? All very simple, all very concise. Which is extremely important, because if you have a domain event that is board game was updated, for instance, like that doesn't mean anything. Like what was updated, like it just doesn't help us at all. Like if you read that, we're like, okay, well now I have to look in the code and I have to actually figure out what's going on. And I mean, we're all developers, we're all kind of like lazy. So why just not make it easier on ourselves, right? So here are a couple conventions for domain events for both the name and the payload. And I'm gonna get into code later, so don't worry. It's not just theory. Like a disclaimer, please do not take these conventions as absolute. Again, they are conventions, they're not guidelines or rules or whatever. Just take them with a grain of salt, or like a kilo of salt, whatever you want. The name, first of all, use past tense, because again, domain events, they represent history, right? So member register, for instance, or register member, or a restock board game, like that's an action that you actually do in your system. It's not something that has happened. It's something that's going to happen or that's happening right now. And trying to make sentences like restock or member registered, for instance, is a valid domain event. Sure, that's all fine and dandy, but you can just create a simple sentence out of it, and you can have more benefits of it later. And the technical stuff is also kind of like not necessary really, because actually it's like extremely unnecessary, because domain events are the things we use for a business, right? We try to understand how the business works, and then we try to put all of that knowledge into domain events. And things about like cache hit register or something, or request IDs or whatever, or like IP addresses don't really belong in domain events. Like if some CEO or some HR person is gonna look at some domain events and they see like a cache key, they were like, so what's that? I'm like, yeah, that's you like, and then you're gonna try to explain cache to them, and you're gonna be in for a while. So good luck with that one. The payload, I don't know, like, can we please hold hands who plays Overwatch? Literally just, okay, that's more. Awesome, thank you guys. More on that later again. So the payload, leave out the technical stuff, right? Again, it's just not relevant. It's just not there for domain events. Again, domain events, right? And keep an eye out for the amount of properties that you have. So it could be that if you at some point feel like you have too many properties in there, like too many data, it could be that you're housing multiple domain events, like 2 or maybe 3 or even 4 or something. Like so. Again, board game was updated, it has like at least 13 domain events, for instance. I don't know, it could be even more. 13 was just an arbitrary number. But keep an eye on that. And also try to use simple objects. Instead of board game stock was replenished and throwing the entire board game entity in there, or something else, like an entire member entity or something in there, just put the reference in there, like create a simple value object that is just member ID that represents the identity of the member. Put that in there, and it'll be like the actual domain event will be way smaller and also easier to look at and everything. And it's just, I don't know, better practice, I suppose. So what does this actually look like in code? It's just this. It's very simple. It's just a simple class that implements an interface. The interface is literally just for type hinting. Like it has nothing actually in it right now. In this example, and in most of my projects, it has nothing in it really. So what we want is we have a value object that is board game ID that represents the identity of our board game, which is a UUID, but that's details because we don't care because we have a board game ID, and also the amount that was replenished. So event sourcing in a nutshell is literally just instead of changing values, we append events. That's it. Well, thank you. Goodbye. No, it's like that's obviously more to it. But if you want to take a look at it in a more data-centric approach or whatever, instead of modifying the columns in your rows, what you do is you just append a new row. You just insert a new row in there with all of the information that for that specific update. So to summarize, with event sourcing, we only store events. So why the heck would we do this? Because how is it easier that if we have like a shit ton of inserts in a table, then like how is that easier than just maintaining like one simple row in our database? How is that easier? Well, I like water. We won't lose information, and what this is that if we have a query, for instance, like if you look at this, then obviously with such a simple query, then you might understand what's going on, or at least you'll probably understand what's going on. But you might you're not sure because it doesn't have a name or anything, right? It's just, I mean, here's a query. Like we can all read SQL, so. But if you go back to this, there's also implicit information that we won't. Wait, I actually forgot something. So if we just take this, if we just have the board game stock was replenished domain event, then that is way easier to look at, and that's way easier to understand than looking at this update, right? And also there's implicit information. Let's say that you have a bunch of domain events, and at some point you start to figure out a pattern between these domain events. Like this is implicit information that you otherwise wouldn't have, because otherwise you would need to create a system that actually saves all of this and creates a log, for instance, and does all these other things. But if you're putting all of that effort into creating extra tools to figure that out, then why not just use domain events, right? Like if it's that important for your business to understand these patterns between domain events, then just use event sourcing. So again, in a nutshell, we know what and when something happened. So yeah, just imagine we have a bunch of events now. They're all like there's a bunch of events like in one table. It's all in there, right? But how do we get to this ordered stuff? Like how do we know which domain events belong to which object, to which board game? And again, I'm gonna take some water. Well, we all know arrays, right? Arrays are actually awful, in my opinion, but they're useful for some things. Specifically for this, an event stream. An event stream holds hold all these domain events, and what an event stream is an append-only array that has an identity, that has an ID. That's it. That's literally it. Like it looks like this visually, maybe. It's kind of vague, but yeah, that's kind of like how it looks. And you just keep adding these domain events one after another, and that is literally how you keep track of these things. And also, an event stream is bound by time. So these event streams, they are tied to our domain concept. Like board game is a concept in our domain name, in our domain, right? But we could also have a member, and a member could also have like event streams and whatever, right? So these things have a life cycle, and they are tied to our objects, these event streams. So okay, but how do we actually record? How do we actually record these events? Well, we do it through our object, but this is not the only way. You can actually record events like whatever way you want, but through our object through a object is the best way to do it, because then you can keep all of the logic in this one class or object, right? This is what it maybe look like, for instance, in our example. In our business, like I talked to our domain experts, I talked to our owners or whatever, and they said, well, to start selling a board game, like we don't need anything really, like we just need the name and the price, like that's all we need right now. And if we have that, then we can automatically start selling, or we can actually start selling our board game. So this is the minimum amount of information that we need to start selling. And you might think, well, this is a static function, and so it must be doing something globally, like storing this information globally or whatever. But it's actually not. Wrong slide, damn it. What this is a name constructor, and this kind of represents just a new board game. It kind of represents just the keyword that you use to initialize this board game. But the thing is that if you use name constructors, which are actually just factory methods, with a fancy name, they actually use the language of the business. So if I look at this, start selling, then that is way easier for me to understand than this. And obviously, this is a simple example, and also like yeah, board games is a simple example. But you can have objects that use events that aren't this obvious, right? So when I look at this is just immediately clear to me like what's going on. So this is the inside of the function. It's very simple. We take the price, or we take the name and the price and everything, but then we create a UUID. Reason for this is because you can have collisions with auto increment IDs. I actually never use auto increment IDs anymore, just because this is way easier, and I want to know the identity before I actually persist to the database. Just because, you know, what if I want to dispatch this over like wire or whatever? Like, what if I want to dispatch this through a domain, like a what's the thing called again? Event dispatcher, or what if I want to do something else with it, right? Like, if I have to wait for my auto increment IDs to come back, like, or if I first have to create a SQL query and then I have to get that thing back, then it's just time wasted, and I just don't like it in general. So then we initialize the board game, and this is because I have set the constructor of this class to private. So the only way to initialize this class is through our static function, through our name constructor, right? Called board game, or called start selling. And the thing about never mind, actually. So then we record the event, and the event is started selling board game. Again, very simple. It's just a simple sentence, and it takes all the information that we need. And when it's recorded, we apply the event. Because as you can see in this entire function, we never actually changed the internal state of this class. Sorry, object. We never actually changed anything. Like we don't assign the ID, we don't assign the name nor the price. So how does it get this information? Because over here we return it. So then you would expect that it would actually like have all of this information that you would be able to get back the name, ID, and whatever, like, right? So that's something that I would expect at least. But all of that happens in here. So after the recording, after the initialization of the started selling board game event has been completed, when that has passed, right? When it's successfully initialized, then we just apply all of this information. And more about this applying later because it's very important as well. So we return it, and then this board game class, this board game object holds our new event, right? Well, we actually have to persist it somewhere. But how do we do that? Well, we just create a function to get back all of those events. So right now we only have one event in there, but this is just a simple function to get that. So we have the events, and then we write them to an event store, which is literally just one table, just a table that has just a bunch of, it's literally just one large table actually. And it kind of looks like this. It looks exactly like this actually. So we have a stream ID, which is the ID in this case of the board game, but it could also be like the ID of the member, it's because the stream ID is directly tied to our concepts, and board game was a concept in our domain. So the stream ID is in this case the board game ID. Then we also have the event ID because it's I want to have all these individual events identified, or to be able to identify them. And then we have the version. The version is kind of weird because you would think that you would have like multiple versions of an event, like version 1 of board game stock was replenished, and version 2 of that was a specific one. But it's actually the version is just the order in the event stream. So if we when we start selling the board game, then that specific event is version number 1. If we replenish the stock afterwards, then that version is number 3 or number 2. I barely can't count, so and you're all listening to me talk, yay. And if we have something afterwards, then that has like 3, 4. It's all sequentially, so it just counts up, right? Then we have metadata for extra information, like IP address, for instance. So the metadata is a thing that. Oh wait, we also have the payload, right? Yeah, sorry. So the payload in this case is just JSON, which we store just as a simple JSON string in there, and then we have the metadata. So the thing between metadata and payload is that the payload is what's important to the business, and the metadata is the extra information that you might use. So in the metadata, that's where you can actually put, for instance, the IP where the domain event was recorded. Like, was it recorded in some like which server it was, for instance, or whatever. Like, you can have all this information in there. So you don't have to store it anywhere else. So it's all nice and packed up, right? Oh, and then we also have the event name and when it was recorded. So we get back the ID and the events, and then we simply just write them to the event store. But now, I don't know if you guys knew, but Cold Express, it's an amazing game. And in 2015, it was Board Game of the Year, I believe. So everyone and their mother wanted to buy this board game, and we ran out of stock. So we actually restock it. But to be able to restock it, we need to get back the latest version, the latest state, or the latest version of that board game, right? So how do we then go from like all these events back to actually the latest state of this object? Well, normally with Doctrine, for instance, or with Eloquent, you would have something like this. You would just like have the ID of a specific thing, and then it would just populate the class with it, right? Well, with event sourcing, it's actually very simple. What you would have is you would also have the ID somewhere. I'm gonna explain that later. But you have it somewhere, and then you get back all the events, and then you rebuild the board game from it. And as you can see, this is again another named constructor. So right now, there's 2 ways to initialize the board game. It's through start selling it, or it's through actually rebuilding it from events. And if we, at some point, like we as a business, have more ways to initialize a board game, maybe to have it as a draft or something, and not immediately start selling it, or to have it like as a duplicate or whatever, like I don't know, then we would also have another named constructor there to initialize that and to create that initial state. So from the start, what does it look like? We have this thing. This looks extremely simple because what it does is it just creates a new instance of the board game, and then it loops through all the events that it got because it accepts an event collection, and then it just applies all these events like one by one, all sequentially, and then it returns the latest object of it, and then it returns the latest version of that thingy. So with applying the event, this looks something like this. You could do it multiple ways. You could actually have another object take the responsibility of applying these events to the specific to the board game, for instance. I like to do it like this because it's all then in one class. It's all very simple because, I mean, like, who cannot read this, right? It's easy as hell. So what it does, it just figures out, it's kind of like pattern matching, but not really, because in PHP we don't have pattern matching, unfortunately. But then what we do is we just look if we actually accept one of the event types. If we do, then we immediately apply it. Otherwise, we just ignore it and it just continues, right? It doesn't really error because you don't need to error. This is the apply method. You know, easy. So yeah, we were actually gonna restart the board game because everyone right now like is kind of like anxious, but like sitting behind the computer, like hitting refresh, like, oh god, they're still out of stock, right? Fuck. I'm not probably allowed to say that. Sorry. So we're gonna restock our board game, right? And then we're gonna get back all the pending events, and then we're gonna write it to the event store, and then like everything is all nice and dandy. So we have then now all of the events in our event store. We are persisting all this awesome stuff, but we actually need a list of our board games because, you know, showing a list of all events that have happened to your system on your page is not very user friendly, honestly. Like, to have to like Control F through everything and then like starts on a board game and then figure out the name and the payload, and it's not helpful really. So we need a listing of our board games. So how do we do that? Like, how do we take all these events? Like, one thing is what we could do is we could literally get back all events and then apply them on the objects, and then have like a shit ton of board game objects, and do that literally on each request, so we can actually load all these events, so we can actually have all of these instances loaded. But that would at some point become kind of expensive. But in the beginning, it's all nice and fast and everything. But if you have like a couple thousand events, not even 1,000, like if you have a couple million events or whatever, or like 100,000 events, then like you don't really want to be doing that in like you know, each request, because your CPU would basically be at 100% each time, and you have to like scale insanely. Like yeah, you don't want to be doing that. So at some point it'll become expensive. So how do we fix this, right? Well, we introduced read models, and read models are very simple things, and the sole purpose of a read model is just to read stuff. I mean, that's it. Like it reads stuff from somewhere. It doesn't matter where. Like the implementation is all just inside there, but we have the interface on the class itself, and we're able to actually read information from there, right? So we are going to have a projection, and what a projection is, like we're going to read, like our read model is going to read from a projection. And what a projection is a projected state of something. So if we have the latest version of the board game, if we have the latest state of the board game, and we put that somewhere, that is a projection of that board game, right? So a projection can be actually several things. It doesn't have to be MySQL, or it doesn't have to be anything. Like, it can be a MySQL table. It can be an Elasticsearch document or something. It can be plain text, or literally whatever you want. Like, if you want to store it as HTML, and that works for you, then go ahead. If you want to store it in, I don't know, something else, then, or like PHP code, if you want to store your whatever. Nah, never mind. Stupid joke. I'm just gonna continue. So. How do we create a projection? Well, we use a projector. How clever! All right, and a projector is actually just exactly like an event listener, but then it does stuff as well. Yeah, so it listens to all of these incoming events, and then it projects then it projects the information that it gets somewhere. So if you look at this table on the right, then you see the projected state of all the events at the left, right? Like, we have a couple board games that we started selling. At some point, we got out of stock, and then we have to replenish the stock, and also we discounted Quantum because apparently it got too expensive or whatever. But yeah, this is the projected state of our domain events. And so what we do is when we get an event, like when we listen to an event, like when it comes into the projector, we just in our example, in our MySQL table example, we just fire an SQL query. So if we started selling a board game, what we do is we just do an insert. If we do like what's it called again, a stock replenishment or whatever, then we just do an update. Or if we remove a board game, then we just delete it, right? So these things are actually very simple. And the cool thing about projections is that they are disposable. Like, we can just throw them away. Because we have the events in a separate storage, like in a separate database somewhere or it's a separate table, we don't actually have to worry about these board games. Like, what we can do is we can just drop the board games and then get back all the events and then just reproject them again, and all will be good. So, yeah, that. And this is actually very simple, very similar to our bank balance, because the number that we see in our bank balance, like online, is not the number that they actually manipulate for the money. That would be ludicrous, right? Like, if you just change the integer and that is like the actual money that you hold, that's ridiculous. No, your bank balance is just a sum of all of your transactions. So what this looks like is we got some money, we spent some money. I think we had a very good night out. And then we spent some more money, and then at some point, like, we wanted to buy a bouncing castle for some arbitrary reason, right? So we spent €600. So all of this adds up to 78, I hope. Seriously, I hope this is correct. It's been a while. So anyhow, but the key thing is that all of this can be recalculated. You know, so we can just throw away that number, and we can then get back at the same result by looking at by just summing up all of our transactions. So with events, the thing is that since we're recording everything, we can actually react to everything. But there is one caveat with that, is that we're typically not event sourcing our entire application. What we do is we only do it really in a very crucial part of the application, like where we can actually draw some business value, where it's important to figure out these patterns between domain events, where it's important to, I don't know, like if you need a lot of accuracy, then domain events and event sourcing, that might be a very good fit for you. So we replenish the stock of Cold Express, right? And now, now we need to tell our customers that we actually have replenished stock, that they can buy the board game now because they all want to play it, right? So we just notify them. Luckily, we can listen to our board game stock was replenished event. So we can have a listener, and what it does is it listens to the event, it goes into the message bus, and then at some point it'll hit the listener, right? And I named it very clever: notify subscribe that board game stock is replenished. Everyone can look at that name and can think like, that's what's going on. Awesome, thank you. I don't have to look at the code right now. And this is lately I even created an exception that literally had 20 words in it. I mean, it might seem overkill, but it was extremely simple to figure out what's going on, right? Even like it's an exception, so like it doesn't really have any logic or whatever. But you know, I thought it was cool. And then it just does its awesome thing, and it just disappears out of life. Anyhow, at the end, all is good. So the thing is that listeners can also have state. So these listeners that we have that listen to events can also have state, and that makes them process managers. And process managers are kind of like long-lived processes, as in like if you need to like figure out if you have to figure out like things between multiple events, not just one event, then you can use these things. So a good example is an administration application, for instance, and the trial ends after 10 invoices. Like it doesn't have, our trial that has nothing to do with time or whatever. It's just that when someone has sent 10 invoices, that's when their trial ends, and that is when they get an email that, hey, person, your trial ended, so give us money. So anyhow, this is how it visually looked like with their process managers. We send some invoices, and at some point we'll hit send, and then this thing will fire off. Like what we'll do is when it actually hits send, we get back the account, and then we call end trial on it, and that'll then also record a new event, which then would then be picked up by a listener, and then the email will be sent, right? So that is event sourcing and projections and whatever, really, how all of that works. But there's one important thing that I wanted to talk about, and that is consistency. So who can actually hold up their hand who has used a database before? I literally want all of you to do this. Okay. Then who has built systems? Keep holding up your hands, please. Just it's an exercise or whatever. Who has created systems that multiple systems that access the same database? Keep holding up your hands, please. Okay. So you might have actually, so the thing how this is called, this is shared state, right? Yeah, you can drop your hands now. Thank you. Or you can like hold it up, I don't care. I mean, or you just start dancing. And anyhow, this is called shared state, right? And shared state is fine. It's just fine. But the thing about shared mutable state, and the thing about shared mutable state, which is like kind of like the bad brother of it, right? Is that everything has access to everything, really, and everything can change everything, and that's kind of like tricky because you don't want to be at some point like have unexpected changes. So what this looks like is you have a database and an application, and it talks to each other, like they're having a cup of coffee or whatever, and then it reads, and then you have some other service and and they talk and read to each other, and then you have multiple services and multiple applications. And I use this very ambiguously, by the way. I just interpret them however, an application service, module, I don't care. But all these things are talking to this one database, right? And this is kind of like something. So everything has access, so consistency will be tough. And what would this look like actually? Like the inconsistency is that you would have, for instance, service 1 having the state of ABC, like it gets back the latest representation of the board game, and this is very simplified board game, obviously. Like we have ABC, right, and then we have service 2, which also got the latest version of board game, right? So right now, at this specific moment, both services have the same representation of board game. But service 1 decides like, okay, I need to change this because of whatever reason, right? So it adds a D. So right now it's ABCD. But the thing about service 2 is it's in a newer server, and it's way faster than service 1. Like service 1 is kind of like jealous of service 2, right? But so it changes to ABX. And then what it does, it immediately persists, and it's like it persists before service 1. So then the current state in the table is ABCX. So what happens then is the slower version, or the slower brother, then persists the latest change, which is ABCD, and then kind of like just overrides it, right? Which is whatever. And then we have service 2 that thinks that the latest state was ABX, just like going mad and just flipping tables, right? I'm just going home later, guys. Like it's just doing all of that bullshit, right? So like you don't wanna have that, and it's a real issue. So the thing is that event sourcing kind of like it actually really helps with this stuff. Like it really helps with consistency, because what you have is if you try to like let's say that our board game has 12 events, so like the latest version was 12, right? And then we discount some board game. But at the same time, we also have a stock replenishment. And both of them in memory, like when running in the process, they have the version 13. But one is always faster than the other. So at some point, the second one, also with version 13, tries to persist, but the event store says, sorry, I already gotten version 13. So you can actually persist this. So it holds you, like it stops you from making these consistency mistakes, right? So then it throws an error and it shows you why you fucked up, basically. Not really you, but maybe your colleague or whatever. Anyhow, what other crazy things are possible with event sourcing? And amazing things are possible with event sourcing. You kind of like have a time disposal at your time machine at your disposal. That's what I was gonna say. Literally one of my favorite movies ever. If you haven't seen Back to the Future, go watch it, please. And report back to me on Twitter. Thank you. So what you have is like what you want to do, or what you can do is that if you want to see what the status of a board game like a year ago or something, you can just get all the events from the beginning until a year ago, and then your board game is in the state of a year ago. Yeah, like you can do the same thing obviously with backups, but event sourcing. You can have, I'm actually going to skip this one because it's so bad. It's just incredibly stupid. You don't even want to be doing this. And you can also just project data to multiple things. So what you can have is you can have MySQL for viewing, and if you want to search, then you can also have Elasticsearch for searching, or whatever you want really. So what you can have is you have two projectors listening to the same event and then projecting to different places, right? Or one of the options is to we're creating a new version of our website, and we want to have a certain amount, like 5% of our users. We want to show them version 2 of our board game listing because it adds some awesome features, right? What we can do is we can also have we can again then have two projectors that project to these different tables. And then version 1 is still working, but also version 2 has all the latest data, right? So that's how you can also do it. You can have the best audit log ever. Because since you're recording everything again, then like we know when everything happened, and you can react to everything. But no change in our system, if that system is event sourced, will happen without events. Like if you're using event sourcing, the only change that's going to happen in your state is through events. You're not going to be modifying columns somewhere. You're only going to be storing events, right? That's the only thing you're going to be doing. Events, 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 events. At some point, you'll even, whatever. You can fix database schema bugs. And what this means is that, like, if your protection is wrong or if your whatever is wrong, then you just drop that thing and fix the schema update, and then you rerun all of the events through it again, and then all is good. Post to Twitter, what you can have is a process manager, for instance, that counts up the amount of users you got, and then at some point, like 1 million or something, because you're the new Facebook, it'll tweet out on your Twitter. So this is, I mean, not like the best use of a process manager, but yeah, I suppose it's possible. And there's actually like a lot more possible. I can actually give it to you forever. So how long do you guys have? How long do I actually have, Raphael? 10 minutes. Awesome. Time for questions then. Thanks for listening. Before I stop, I want to talk about this thing for like at least a minute, or maximum a minute. This is a project that Sean McCool and I started doing. And we were learning a lot about D2D CQRS and event sourcing a couple years ago, and we didn't think that there was enough there was enough content out there, but actually like insanely good quality content, like video-wise, audio-wise, and just also the philosophy, because with all the things that we saw is that it was mostly practical and some theory. But we wanted the philosophy behind why you would use these, like how you would use it and why you would use it, the theory behind it, but also the practicalities, right? So we created Event Source Free, and it's a running thing. It's a living project. So the thing is that we are releasing videos each week, and we get feedback from our users, and then if they spot something that they want to have in some certain episode or whatever, then we revisit that episode. Like we try to actually listen to whatever our customers want, like whatever our viewers want, and then we just might revisit them later, right? Right now it's because we're working on it, like we kind of released early access, so it's like 70% off or something right now. It's insane, actually. So if you want to have like a free episode or whatever, which is basically like, if you don't know what a model is, by the way, like it's just a model, then you can sign up for the free episode, and you'll get the best explanation by Sean about what a model is. It's insane. Like I kind of like bow to the dude, like awesome, man. That's great. Anyhow, thanks so much. Thank you for Nick Spelt for like one tiny detail in this presentation. Love you, guy. And are there any questions? Oh wait, I'm gonna throw it, dude. What the hell? No questions. I mean, go ahead. You have to actually like talk in the thing.
Okay.
There you go. That works.
What is the best database to store, or the best data store to store the events?
What's the best way to store events?
Yeah, exactly.
I've used MySQL. But you can also, can I get it back because I want to throw it again? Thank you. I've used MySQL, but you can use whatever. I know Greg Young has his own implementation of an event store, which is called Get Event Store. That, like a year ago, was kind of like in its infancy phase, but right now it's actually pretty competent. And with a new project, I would actually use Get Event Store, just because it has all these awesome features like stream processing and all these other awesome stuff, like actual projections built in. So yeah, I would use that, but you can use whatever really. I mean, I started out just using a text file as my event store, like literally just throwing text in there, and then each new row or whatever was just a new line. You can do that. You can use a CSV file. You can use Twitter. I literally looked at like if I could use Twitter as an event store. Apparently, it's not possible, unfortunately, right? Oh well. So yeah. Please, someone in the back have a question? Thank you. Oh, it's gonna go so wrong. Oh boy!
Hello.
There it is.
Okay, cool. So for some of us who've on legacy projects which have had mutable data for a very long time, have you ever seen a project that's managed to go to embed sourcing, or is it just something for greenfield projects?
For new project, yeah. So you're asking if it's only for greenfield, right?
Yeah, pretty much.
Okay. It's definitely not actually for greenfield. It works extremely well for brownfield. I think it's brownfield, right? Yeah, brownfield applications as well. The thing is that what you could do is you could isolate like a certain part of your application in your legacy application that actually needs a lot of attention. So what this might be is like if you're handling invoicing or something in your application, or like there's this very crucial part. Like what you could do then is tie a knot like a bow around the rest and just remove that, like surgically remove that part from the application and just event source that one and like put it in a different application or whatever, right? Or put it in the same application. But yeah, it's definitely also for older applications. But there are some things you have to do. Like instead of with the board game started selling board game event, for instance, what you would have what you could have then, for instance, if you have a legacy application. If you could have a board game from legacy project, for instance, like imported board game from legacy project, that could be an event that has all the information in there. Like it's not like a good domain event or whatever, but it actually is a good domain. It's just fine. But what you could do then is like have all of the information that you need for the initial version of that, for the version that you had, and then use that as the as the initial domain event. Does that make any sense? Like, so you just create a new board, you just create a new event to import all of the old data, and use that as the starter. I mean, that's how I would do it. Yeah, that's actually the only way you could do it, because you need events to change state. So you just create a new event. Any other questions? Oh, it works again? Oh, thank you. Feels like, oh my God, I caught it. Nothing on the hand. Okay. Jesus. Oh my God, dude. Jeez. Oh boy. Oh my God. I actually don't feel bad at all, honestly. Like, I feel awesome. I'm glad I did that. It's broken. I'm pretty sure it's broken again. Like these things should be more sturdy. I'm gonna, give it.
It doesn't. Oh, it still works.
Oh, it still works.
Nice throw.
Thank you, I suppose.
So you mentioned MySQL is a good storage for these events.
Yeah.
I was wondering what number of events you've handled in the past was as a maximum, because I can imagine with lots of velocity and changes, it might get quite complex.
Sure. Like the systems I've actually built, like the event source systems that I've built haven't grown that big. So they've only supported handled like a couple thousand events. But I know that MySQL can handle up to millions of rows. So then theoretically, you would also be able to handle up to millions of events. So I would, yeah, I mean, especially in the beginning, like if you're just trying something out, or if you're just implementing it very quick, or whatever, then you could definitely use just use MySQL. And also, what's possible is then you can later just migrate to a different event store that may be like Cassandra, for instance, that can actually scale very well, or actually get event store if you want to do that. So you can always the initial version that you use, or the initial event store that you use, doesn't really matter. It's just, like you have to actually get going, and you have to start creating these events and storing these events, and then later you can always change. Like you can always migrate to some different version if you wanted to. So yeah, but MySQL is just fine to begin with, in my opinion.
Okay, thank you.
No worries. No worries. Anything else? Okay, before Raphael gets up here. Oh wait, there's another question? Oh, yeah, you have to throw it then, because I'm not gonna do that.
I'm not going to throw it.
I'll just break it. It's ridiculous. We built this city.
Thank you. All right. So what would you do, how would event sourcing work when you change the initial model that you're working with? For example, the board game. It initially required the name and the price. Mm-hmm. What would happen if you suddenly, your boss comes back and says, like, I need to have the amount of stock as well? Yeah, that's common, honestly. What you can do then is you can create a board game, start selling board game version 2. That's literally the name. Started selling board game V2. That's an example, and which has the newest version of it, which has all the new data, right? And then at some point,
It really depends, because like if you can fill this data out yourself, then what you can do is you can create a migration that that kind of like moves that creates this new event and then persists it to the event stream, right, to the event store, and then at some point when you've actually migrated, when you've stored that new version of the event, so it starts on board game version 2, at some point you can. Wait, I'm explaining this actually well. Okay, so well, the thing is that you can just create a new version of it. That's it. Like you just create a new version of it with all of the old information, but also with the new information. And at some point you just do a migration. And however you do that migration, it doesn't really matter. Like if you need input from your users, then what you can do is you could, when they log in, create an explicit create a pop-up modal or whatever that requests the information that you need, and then store a new domain event, right? So yeah, you have to get the data from somewhere, and then it's add the event to the event stream, and then what will happen is when you replay all of these events back, then that event will also be applied. So yeah. Or what you could do, this is kind of like frowned upon, you could edit the initial event. I mean, if you know what you're doing, it's like I know, like you're not God or whatever, but it's possible to just go into your event store and modify the initial events, especially if you're like early, like especially if you have a startup, for instance, and you're like a couple weeks in, and like you figure out that you actually need like another property in there, you can just change it, honestly. Like you probably have a couple hundred events or something, so the impact might not be that weird or awful. So yeah, like yeah, but I would create a new event. Just to create a new version of the event called something v2 or v3 or v5 and 4. So yeah, I would do that, really.
All right, thank you.
No worries. Well, that's it. Follow me on Twitter if you want to. You don't have to, honestly. If you want to rate my talk, then you can either scan this QR code, or you can go to this link right here. And if you want to play Overwatch with me and my amazing team, then you can add me on Battle.net right here. I'm not going to stand in front of it. Yes, my name is very fast, I know. It's a stupid name. But yeah, I think that's my talk. Thank you for listening again, and have a great conference. Thank you.